Welcome to Big Bang Data Science Solution, the 15-week free training program in data science and artificial intelligence in collaboration with a few Moroccan universities. My sincerest apologies for taking almost 20 minutes to start today's session because unfortunately we have to wait for other students to join us. So, but nevertheless, you are going to be dismissed on time. So now we are in week number 5 and session number 1. Let's go through very quick, go through what we have covered so far from the helicopter view. In week 1, it was an introduction to the program, and we also learned why do we need to become a data scientist. Then we moved into week number 2, and we learned about the first phase of CRISP-DM, which is going to be a methodology that we'll be using in the program, and also a methodology best known for analytics. Then in week number 3, we built. It was a crash course in Python. We built a foundation of Python programming, and in week number 4 we moved into the second phase of CRISP-DM, and that is understanding the data. And of course there are many methods that you could use, that you could utilize to help you understand your data. And to name few, we could use statistical analysis to measure the data from different corners. We could use data visualization. We could use descriptive analytics. We could use exploratory data analysis. There are many methods that we could use to help us understand the data. And the more you understand the data, the better you will design for your design solution. So in this week, we are still in the process of learning basics about our data. And in last week, we learned about statistical analysis, how to measure a few things. Of course, we are going to continue building up what we have learned from week number 4. And today we are going to learn about visualizing the data, transforming the data from figures, from numbers, from digits into a meaningful graph to represent unseen, unknown, envisioned elements of the data. So that is the plan. So once we have a clear understanding about the data, then we are going to move into fixing quality issues of the data. So week number 6 is going to be data pre-processing, and week number 7 it is going to be another data pre-processing, and then we are going to move on. Week number 8 we are going to move into building models. Then we are going to build some supervised learning models, and it's all about classification, because the type of the data that we have is classification. Okay, so we are going to go through the presentation first. Let's simply go through the presentation, and we will dive into the course. Hopefully you have access to the recording, to the training materials through Canvas. If you don't have access yet, please ping me on WhatsApp. I will be more than happy to assist you further. Okay folks, so we are still working for this RE insurance company. We are still working for this RE insurance company, and our job is to help the business. Fix the issue they are struggling with. Okay, so in spite of having a fraud investigation team that investigate up to 30% of all claims made, the business is still losing money due to the fraudulent claims. That is the problem. This is the problem that we're trying to fix. And if you simply think about it, and we learned this in previous cases, in previous sessions, if you think about it, this is a very broad and vague statement. You won't be able to analyze or find a better solution for this problem unless you spend time understanding exactly what is going on, and also understand how we can transform this problem statement into an analytical and quantifiable statement. So we talked about the CRISP DM. In CRISP DM, we started by spending time understanding the problem. So we learned about the objectives. We learned about how to frame the business problem or the business statement. And not only framing it, but we need to frame it and assess the feasibility of framing. Then we learned that we are going to need any measurement to measure how successful we are towards the end of the program, towards the end of the project. We learned that we are going to need a target variable if and only if we know that we are going to do some prediction. So to predict the probability of something to happen in the future, to predict the likelihood something is going to happen in the future, we have to have a target variable that we want to predict in the historical data, and of course we need to learn the mathematical relationships of this historical data to be able to use it to predict the probability of the future. Then we talked about the identifying the approaches. There are 6 approaches. There could be more, but as far as I know, there are 6 approaches. 4 approaches that are most common: descriptive analytics, predictive analytics, diagnostic analytics, and predictive analytics. Of course, there is going to be the two last approaches are optimization and simulation, but they are not common. Then we learned that we need to identify a deployment plan if there is going to be any deployment. Otherwise, as I mentioned earlier in one of the sessions, that 70%, it's been approved, it's been studied, that surveyed that 70% to 80% of the projects, of analytical projects, fail because either you misunderstood something at the beginning, or you were not prepared for the end of the project. Then we talked about we need to have a plan. This is the start date, this is the end date, and this is what do we need to deliver for a certain period of time, without promising the business that we are going to do it, because the difference between the traditional project versus the analytical project is with the analytical project, still the traditional project applies, methodology applies, but unfortunately, since we don't know the data, we don't know what to expect, we don't know we cannot promise something or anything to the business. Then we need to identify the team and stakeholders, just to make sure that we are on track. We need to build a very strong relationship with our stakeholders. And if you don't have a data yet, or there is a data but it's not available at your fingerprint, it's not available, it's there, it's scattered across many resources, including websites, including the cloud resources, including servers and databases. So you got enough data, you got a lot of data, but it's not yet collected. It's not yet ready for you to start working on. So you might need to use the analytical base table methodology or process simply to determine what you are going to need as far as the data is concerned. So someone please mute yourself. Someone please mute yourself. I don't know who's talking. Yeah, let me see if I can fix that again. Yeah, mute all. Okay. Okay, so by now you should have clear understanding of what needs to be done to understand the problem that you are about to tackle using analytics. Okay, and then we are going to move into data. So now we got a data, and of course you need to spend another hours, maybe weeks, to help you understand the data that you'll be using. You cannot use the data as is. The data as is a raw data. It could be the right data, but you cannot assume that your data is ready. You cannot assume that. So we need to spend time manipulating, wrangling this data that you have collected and read into whatever platform that you plan to use for your analysis. And in our case, we are going to be using a Jupyter Notebook or Python. So you need to apply some methodologies or scientific methods to help you understand every bit, every element, every part of your data, and especially understanding the quality of this data. Why? Is because just in the for your information, the machine learning, they accept any data, but the quality of the finding, the quality of the discovery, the quality of the insight, it's totally related to the quality of the data you are feeding into this machine learning. So it's garbage in, garbage out. But more than that, it's garbage in, danger out. So we need to learn the quality of our data, and we need to fix that quality before we are ready for feeding this data into machine learning. So you need to apply ADA, exploratory data analysis, and data visualization, statistical analysis, and of course at the end of the day you need to come up with a book, with a document describing anything, everything that you found about your data. That is very important. Okay, so yeah, there is no week 5 yet. I'm gonna simply grant you access to the week number 5 at the end of the session. Okay, so any question, any concern, any doubt so far? Even in Arabic, I don't have a problem. عندكم سؤال شي استفسار yeah, I'll give you a minute to see if you guys have any question, any concern. So I'm gonna yeah, please go ahead, let me know if you have any question, any concern. Don't be shy. And one of the reasons why we switched from the YouTube live streaming method to Zoom is to give you guys a chance to ask me your questions directly. So please let me know if you have any question, anything that is not clear, أي حاجة غامضة ما مفهوماش, just let me know, then we can figure it out together. Questions? What is the usage of the code book quality report? Very good question. So the quality book and or the report is what you are going to need to use for data preparation. In the data preparation, you need to know what do you want to fix. You have outliers, for example. You already have them in this quality book. In this quality book, you should talk about outliers. You should talk about the duplicates, about categorical data, about the distribution of your data based on what you have learned through applying ADA and data visualization and statistical analysis of your data. So هذه هي الخريطة، خريطة الطريق اللي تستعمل باش تقد البيانات اللي عندك. It is the roadmap that you'll be using, that you'll be utilizing to help you facilitate the process of pre-processing the data. إلا ما عندكش خريطة الطريق ما غاديش تعرف اشنو غادي تقاد. You are going to assume that everything is مقاد عندك, and that is not the case. Okay, Ahandor, are you clear? Is there a standard? Yes, I have a standard, but just be creative. Just be creative. I think I have a standard. Let me see. Yeah, I might have a standard. I think I do. I think I do in one of the presentations. Yeah, let me see. Yeah, here is a standard. So this is a standard. Of course, I mean, I don't want you to be a slave of this standard, but it does have everything about this case. So you need to talk about the various data type and the various sources where you are getting the data. Talk about the storage and talk about your understanding about data. Talk about the summary, type, range, missing fields, primary list of variables. Then talk about the variable hierarchy, data transformation. Talk about the type of central tendency, the mean, median, mode, normal distribution, the skewness, measures of variability, measures of relationship, distribution, transformation, etc. So it really depends on the case that you are working on, but there are a few things that you need to mention. Whatever you think you are gonna need next for the following phase, you need to document it. Okay, that is very important. Okay, in which format the ABT is sort of a report. So ABT is not a report. ABT is used in case that you have data but it's not available yet. شركة كتقول لك عندنا البيانات, we have data. Where is the data? It's somewhere. It's scattered across many platforms, many resources. ما عندكش البيانات في ملف واحد. انت مثلا البيانات كثيرة جدا و it talks about عندك بيانات على ال clients, you have data about clients, you have data about the claims, you have data about the payment systems, payment processing, payment transactions and everything. You have data about the policies. So you got so many data. But from your own perspective, based on your understanding of the problem, out of this data, what do you think you are going to need? So this is a typical ABT. So we are going to do analytical solution, then we have a target variable, then we got a domain, another domain concept. This is domain concept related to claims. This is domain concept related to clients. This is the domain concept related to payment. Another domain concept related to policies. So you got so many, you got a vision. So ABT is simply a vision of or about what you are going to need as far as the data is concerned. يعني عندك واحد الفكرة مسبقة على نوعية البيانات اللي غادي تحتاج based on your understanding of the data. إلا ما فهمتيش إلا ما فهمتيش based on your understanding of the problem. إلا ما فهمتيش المشكل ما غاديش تقدر تحدد نوعية البيانات اللي غادي تحتاج. إلى البيانات كاينة ولكن ما كايناش موجوداش yet. So that is ABT. Okay? And data, it could be anywhere. It could be in operational databases. It could be in data warehouse. It could be flat files. It could be in external data sources. It could be anywhere. And the ABT is what you are going to need to collect the data from different sources and just store it in a place where or in a format where you are going to start using it. Okay, so this is the worst case scenario. The worst case scenario is the business, they have a data, they have mountains of data, but the data is not ready for you yet. So you need to come up with a plan. Based on your understanding of the problem, then you could have a better plan. إلا ما فهمتيش المشكل ما غاديش تقدر تحدد لنا البيانات اللي غادي تحتاج في التحاليل ديالك. Okay. Okay. So now we are going to move. So this is the code book or the quality book هي اللي غادي تستعمل في data preparation. Data preparation, which is going to be next week. We are going to learn how to deal with duplicates. We are going to learn how to deal with missing values. إلا سولتك مثلا سؤال بسيط جدا هذا في الانترفيو بغيت نخدمك وسولتك okay, if we have a data and we have a missing values, what are you going to do? تقدر تقول لي delete them. Yes, you could delete them, but that is wrong. خطأ. تقدر تقول لي impute them. Yes, خطأ. So what is going to be how do you deal with missing values? So for your quality the code book or quality report غادي تهضر لينا على missing values وغتهضر علينا على الحجم والتأثير then you are going to talk about how you are going to deal with missing values. ما يمكنش تجي تقول لي we are going to delete them. Okay, so what if you have 50% of your data has a missing values? غادي تقدر تحيد ليها 50% of your data, then you are going to end up having a very small data set. So deleting missing values is one option, not all the options. So خطأ إلا قلت لي I'm going to delete them. You could have told me تقدر تقول لي نقدر نحيدهم إلى عندي هذه نقدر ندير لهم imputation if you have this conditions. نقدر ندير لي use robust machine learning if you have these conditions. So your answer to a data preprocessing question has to be in the option format. تقول لي نقدر نديروا هذه ولا هذه ولا هذه ولا هذه if and only if we have these conditions. ما تقدرش تقول لي we are going to delete them and that's it. That is a wrong question. You have outliers. Then how do we deal with outliers? واش نحيدوهم واش نخليوهم? Or again based on the quality of outliers. Then we need to deal with cardinality or hierarchy. We need to learn how to transform the categorical data. What format are we using? The NP-ware mapping, should we be using the one-hot encoding, dynamic variables, labeling coding? What would be the best or the potential format of transformation that we'll be using? Then you have skewed data. Should we unskew negative way or positive, up or down? Then how do we need to normalize or factorize or binarize, standardize? Do we have correlation analysis? One is to be done with that. How do we aggregate and bin? How do we decompose data if we are using if you are using time series analysis. there are two things كاين جوج الحوايج هنا ودرتهم بالحمر. هادو هما the best or the most important steps in data preparation and data preprocessing, and that is feature engineering or feature creation and feature selections. They are very, very important. And believe me, up to 70% هادشي كامل تلنا it is going to consume 70% of your time. 70% ديال الوقت ديالك راه غادي يضيع غير في business understanding, data understanding, data preparation. If you feel like إلا حسيتي براسك بأنك راه يعني راه دغيا still modeling راه كدير شي you are doing something stupid. You are doing something very, very stupid. Okay, if you feel like you are spending more time on the first phase, you are doing something right. رغم أنك يعني it does consume time, but yet you are doing something right. Salma, we put the mean instead of what? Understood? No, you cannot put the mean. You cannot put the mean. Yeah, yes, you could put the mean. You could impute using the mean, but when? You could impute using the mode, but when? You could impute using the median, but when? You could impute using any different measurement, but when? Imputation is one option, not all the options. But you need to understand when do you need to use an option versus other options. No, you cannot delete, you cannot impute without understanding why. Imputing is it has some conditions. ماشي غير غادي تجي تقول لي we are gonna دوك missing values غادي نغيروهم بالمين. لا missing values غادي نغيروهم بالميديان. علاش المين علاش الميديان؟ why? That you need to understand that. علاش غتحيديهم؟ علاش غديري الامبيوتيشن ما تحيديهمش؟ So you need to understand when and where to use a method of deal with missing values. وهذاك الشيء كامل you should have it in your quality book. You should have it here. Okay? إلى عندك مثلا في البيانات ديالك إلى عندك 3% missing values 3% 3% or 5% or 1% of your data has a missing values. Do you need to impute with the mean or mode or median? We are not going to impute. It's just 10%, 5% or 1%. Just delete. ولكن إلى عندك مثلا 50% of your data has missing values, then the question is, do we need to impute with the mean or the median, assuming it's categorical? Of course, with these missing values, if we have outliers, we need to do the median, because median is not sensitive towards outliers. إلا ما عندكش outliers, then we could do the mean. Then if your data is categorical, then we are not going to do the mean, we are not going to do the median, we are going to do imputation with the mode. So you got to understand the quality of your data, and you need to determine what needs to be done in terms of fixing them. Okay, folks, so the data ADA for short is the exploratory data analysis. كاين واحد عالم أمريكي عالم في الرياضيات و statistical هو he's the father of this ADA وسميته جون توكي. جون توكي وعنده كتاب exploratory data analysis، وهذا هو هذا الكتاب اللي كيتستعمل دابا، ومجموعة ديال الأمور اللي علماء بيانات دار scientists they are using in the exploratory data analysis of the data given to them is from the John Tukey. So John Tukey discovered the 5 number summary. انت في اطار فهمك للبيانات خصك تفهم 5 number summary of your data. So what are these 5 number? Is the extreme, minimum, maximum, the median and quartiles, and of course the skewness and the distribution. خصك تفهم في البيانات ديالك إلا كانت هذه البيانات numerical, then you need to understand the mean, the minimum and the maximum. We need to understand the 25% of your data, the 75% of your data, and of course this 50% of your data. If your data is categorical, then we need to understand the mode, the frequency, and the uniqueness of your data. Okay, and with why do we need ADA? Why do we need ADA? Is detect outliers, test your assumptions. Sometimes you need to assume something of your data, assuming that if your data is normally distributed, then we need to check. Sorry guys. So then you need to identify how we can transform the data if it's skewed. So ADA is used to help us understand and explore every bit of the data in terms of the quality of this data. So we have to with ADA we are going to use it's going to help us to understand the distribution, the quality, the outliers, the correlation and interrelationship, subset of interest, suggest function relationship. It is going to help us to get to know the data better. And remember, knowing your data better, it is going to help you design a better solution. Okay, so EDA data visual. So that is EDA, and EDA could be done. EDA could be done using statistical analysis that we did last week. It could be done using descriptive analytics. It could be done using data visualization. So today we are going to talk about how to transform the elements of the data into graphs, into insights. So this is something that I found online. I mean, with data visualization is 4-part. You know, there are some graphs that we can use for comparison, comparing elements of your data, comparing especially categorical data. So there are some graphs that we could use to understand the distribution of the data, how the data is distributed, how the data is sparse or dense compared to the mean of this data. So we use data visualization for decomposition to help us understand how the data is being composed, and also the data can be used to help us understand any hidden relationship between elements of your data. And not only that, it is going to help you to understand the direction, the direction of this relationship. So there are many graphs that you could use, but the most common graphs that you could use is we could use it depends on the type of the data. So you could use the bar plot for categorical data. We could use histogram, the box plot for the 5 number summary of your data. We could use density plot, which is similar to bar plot, to help you understand the distribution of your data. Oh, sorry, it's the histogram. Density plot is similar to histogram. Histogram could be used for continuous data, for numerical data. We could use what else? Yeah, scar plot to determine the relationships between any elements of your data, and of course these elements should be independent and numerical. And we could use heat map to understand the correlation analysis of your data. Of course, there are many graphs, but these 7, 6, 7, 8 graphs are the most common graphs that you could use in data visualization. Okay. So the rest about the presentation is talking about the properties about this graph. So we talked about the bar plot. Bar plot is used for comparison, is used for categorical data, and is used for comparison, comparing the uniqueness of your elements of categorical data. And of course, there are many graphs, many bar plots that you could use: horizontal, vertical, stacked. So I'm going to pass. Then histogram. Histogram is used for continuous data. It helps you understand the distribution, and of course, it helps you understand not only the distribution, help you understand the skewness of your data, the curtices, how fat or how thin the distribution is, and also it helps us to determine any outliers. For example, you see this is with histograms. We were able to identify one element that lives too far from the majority, and also with histogram we understand that the data is not normally distributed. It's skewed to the right or skewed to the left. And scar plot is used scar plot is another graph that we could use to help us understand the relationships between 2+ independent numerical data. It's not used for categorical, it's used for numerical data relationship. يعني الفهم العلاقات الرياضية المخفية الموجودة بين يعني the data elements. Is two elements strongly correlated? And if this correlation, what is the direction of this correlation? Is it negative? إلى واحدة طالعة الأخرى خصها تنزل، ولا واش they are going the same direction? Means إلى طلعت وحدة كتطلع الأخرى، إلى نزلت كتنزل الأخرى. That is going same direction, or they could go the opposite direction. أعطيكم مثال على correlation. مثلا في خدام على شي بروجيكت ديال مبيعات المنازل، يعني house price. درتي correlation وفي هاد الهاوسز عندك بزاف ديال variables. عندك البرايس، عندك الفوتج، عندك اللوكيشن، عندك number of rooms، عندك age of the house. إذا كان العمر ديال المنزل كبير، البرايس غادي ينزل. يعني ما حد العمر يعني بحال الا قلتي مثلا الى عندك الدار ديال ايام بني 50 عام، يعني البرايس ديالها غادي يكون نازل مقارنه مع الدار اللي يلا تبنات 5 ايام هذه. So the age goes up, the price goes down. لا هذه مثلا باش تعرف يعني بان the price and the age they are in the opposite direction. واحد إلا مشى إلى طلع واحد الآخر كينزل. An example of correlation that goes together, they go the same direction. Number of rooms. إلا عندك دار فيها بيت وحدة، يعني البرايس ديالها يعني بيت وحدة ثمن غادي يكون عادي. إلا زدتي 2 بيوت ثمن غيطلع، زدتي 3 البيوت ثمن غيطلع، عندك 4 البيوت 4 rooms, your price is going to go up. So the number of rooms and the price are going they are strongly correlated, and they are going in the same direction. في المثال الأولاني the price the price of the house and the age of the house they are strongly correlated, but they are going the opposite direction. This could be done through scatter plot. scatter plot كيعاونك تفهم واش كاينه شي علاقه ما بين الفاريبلز ديال داتا. Number one. Number two, اشنو هو direction, what is the direction of that relationship if any. Then line plot is used to connect the dots, and it's used for time series. line plot كيعاونك تفهم الbehavior هو I don't know, I forgot the Arabic now. The behavior. What is behavior in Arabic? I totally forgot. So the line plot helps you to understand behavior of a phenomena of a movement, يعني تحركات ديال something in your data. So look, yes. So look, شكرا أخي الكريم. Yeah. So look, yeah. I know it, ولكن ما حضرتش يعني it's not I couldn't think about it. Yes. هذا اللاين بلوت is used باش تفهم السلوك ديال شي variables في البيانات ديالك. مثلا بغيتي تفهم the behavior of the price, كيفاش هي البرايس ديال المنازل خلال the last 20 years 20 عام هذه. كتشوف طالع راه غادي نازل وشويه كيطلع، يعني you understand the movement of the price through time. Okay, box plot هذه مزيانة. This is another method that we could use. had box plot, they are used to visualize the 5 number summary of John Turkey. تستعمل باش تعاوننا نفهموا دي الخلاصات الخمس ديال البيانات ديال. And this box plot, what it does, it helps us to understand how the data is being sparse or dense. So it helps you understand the sparsity of your data and the density of your data, and of course it's used to understand anything that is an outlier. An outlier here is simply an element of the data that lives too far from the majority. So with the box plot نقدر نشوفوا واش نقدر يعني نكتشفوا واش في البيانات اللي عندنا واش فيها شي outlier. Okay, so a box plot we are going to help us understand the percentiles, the outliers, the percentiles 10%, 50%, 20%, and 75%. Finally, correlation analysis. يعني correlation, the difference between correlation and scatter plot. Scatter plot it is going to tell us if there is going to be if there is any type of relationship between elements of your data and the direction of that element of that relationship. Correlation it is going to give you the value of that that relationship. A correlation, the value for correlation analysis is between 0 and 1, and we'll talk about correlation later. So correlation is similar to scatter plot, except that you are going to get some values, and it is the value is going to be between -1 and 1, not 0 and 1, -1 and 1. And in terms of correlation, and in terms of correlation, we are thinking looking for 3 correlations. يعني كنقلبوا على 3 الأنواع 3 الحالات ديال correlation. Number 1, number 2, and number 3. Number 1 is the correlation between X and X. Your X, the variables of your data. Then the second one is correlation between x and your y. The third one is x and itself. And this correlation always going to be between -1 and 1. Of course, you got a 0 in there. So the correlation between x and x, we are interested in a correlation that is closer to 0. يعني إذا كانت شي correlation between x and x هي قريبة من 1 أو قريبة من -1 خصنا نحيدوهم. This is x and x. X and x, we are going to remove anything that is closer to 1 or closer to -1. ولكن غالبا ما كتلقاش -1 كتلقى ال 1. Correlation between x and y, it is going to be also between -1 and 1. So the correlation between x and y, we are going to keep anything that is closer to 1. Anything that is closer to 1 or closer to -1. So we are going to remove anything that is closer to 0. Yeah, anything that is closer to 0, we need to remove them. Okay, for x and x, we are going to remove anything that is closer to 1 or -1. We are going to keep only anything that is closer to 0. For correlation between x and y is the opposite. We are going to remove anything that is closer to 0. And we are going to keep anything that is closer to 1 or -1. For the correlation between x and itself is always going to be a 0. دائما غايتولي تكون 0. Okay, and there are 3 types of correlation: Spearman, Kendall, and there is a third one: Spearman, Kendall, and I forgot the third one. And to the correlation analysis, you need your data has to meet 4 conditions. Number 1, your data has to be pairs. Number 2, your data has to be normally distributed. Number 3, your data has to be numerical data. And number 4, your data has to be real, not transform data. Okay, so let me stop here to see if you guys have any question. Let me stop here to see if you guys have any question. Yeah, Pearson, yeah, Spearman, Kendall, Pearson. Thank you, sir. Thank you, Mehdi. I know it simply ما اخترعتش فكرة عندك أفكار ولكن ما كتطيحش لك الفكرة في اللحظة اللي بغيتيها. يعني ذاك الوحي ديالك يعني got lost. Yes, there are 4 Spearman, Kendall, and Pearson. Okay, and of course you are going to deal with spatial data, and you could deal with network data, network graphs, and finally you got some quality book. And thank you. So any question, any concerns, please? Any questions, concerns, please? Thank you, Ismail. Yeah, thank you. شباب عندكم سؤال، عندكم استفسار، عندكم
Yes, sir.
Yes, sir.
My question is about outliers. So, how we can avoid the effects of outliers?
We are going to learn outliers next week, inshallah.
Okay.
Okay, yeah, we are going to learn outliers. Of course, next week we are going to learn about outliers, missing values, duplicates. Okay,
Okay.
and stay away from graphs like this. When you are building a graph, please bear in mind that the graph should be as simple as possible. Number one. Number two, the graph should tell a story. يعني من كتشوف هاد الجراف يعني مباشرة خصك تفهم اشنو كيدور على البيانات ديالك. مثلا إلا عطيتك هاد الجراف هادي جميل, it's beautiful, it's a really beautiful graph, but does it tell a story? No, it doesn't. إلا بغيتي تبريزنتي هادي البيزنس ديالك, البيزنس اللي خدام عليه, غادي يسولك what is this? Yeah, it's a beautiful piece of art, but it does not tell anything. And if it does, it's so complicated, the story that is telling. يعني ابتعد شوية على ما تحاولش تكون يعني smart وبغيت دير شي حاجة اللي هي beautiful, but if it does not tell a story, then whatever you built is useless. So just make it as simple as possible, and just make it also make a graph that conveys a message to the business. إلا كنت خدام عندي وصفتي لي هادي, أنا غادي نسولك what is this? What this is? I mean, yeah, it's a beautiful, extremely beautiful piece of art, but that's it. Does not tell any story. So stay away from building some complicated graphs that does not convey a message. What are the main measurement of the correlation? There are, I don't understand your question, but the measurement of the correlation analysis is always going to be between -1 and 1. So always going to be between -1 and 1. -1 and 1, and of course we got a 0. So if the value of that correlation is above 0, it's negative correlation. It's below 0, it's positive. I'm sorry, if it's above 0, it's positive correlation. If it's below 0, it's negative correlation. If it's closer to 0, it's neutral. So example of positive correlation is correlation between number of rooms versus price of a house. An example of positive negative correlation is age of a house versus price. The relationship between the natural relationship is price of a house versus visiting Morocco, or playing soccer, or number of cats, number of kids that you have. So they totally don't have any relationship whatsoever. So at the end you are going to get -0, -1 and 1. So those are the values of the correlation analysis. Okay folks, so now we are going to move into coding. So we are going to move into coding. So please go ahead and fire up.
Please, one question, please.
Yes, sir.
What is the best way to represent variable on score? I'm talking about well-being score, for example. We have 5 items of scores. So how to represent this score?
What do you mean present? You mean building graphs?
Graphs, yeah. Exactly.
So for scores, the best way to present them, since they are numerical, is histograms and density plot.
Okay, we analyze it like a quantitative variable.
I don't understand your question, brother.
we analyze these variables like quantitative variables.
Yes, it's a continuous. You could use if you are analyzing bivariate, univariate. We are going to use either density plot or histograms. If you are using bivariate or multivariate, we are going to use the scar plot. إلا كنت كدير غير one variable تقدر دير density plot or histogram if your data is continuous. إلا بغيتي دير جوج يعني two variables we want to analyze them, we could use, and they are numerical continuous, then we could use the scar plot. Do we have other? Yes, we do, but try your best. Try to find a graph that represents your data better. So there are many graphs that you could use, but use the one. The golden rule is the best graph is the graph that tells a story. Yeah, Mehdi, can we use correlation analysis? Yes, you could use the correlation analysis to reduce the dimensionality of your data. How do we do that? So in the previous session, we learned about reducing the dimensionality of the data using the prior knowledge. So we are going to reduce the numbers of variables. We are going to eliminate any IDs. We are going to eliminate any constant variable. We are going to eliminate any time series in any days unless we are doing time series analysis. We are going to eliminate any too personal information. We are going to eliminate the cardinal or hierarchical data. That is called prior knowledge. For the correlation analysis, if it's x versus x, we are going to eliminate x versus x, x versus x. We are going to eliminate anything that is closer to 1. We are going to eliminate this part. If it's x versus y, we are going to eliminate this part. Yes, we are going to use correlation analysis in this exercise to reduce the dimensionality of the data. Okay? Mehdi, clear? The fact of having a result, no. If you have 100% result, إلى عندك result ديالك كتساوي 100%، you are doing something stupid. You are definitely doing something stupid whatsoever. إلى لقيتي الريزلتس ديالك 100%، يعني راك درتي شي حاجة خاطئة. There is no 100%. So it could be 100%, improved to 100%, yes, but if the first time you get 100%, you are doing something wrong. Either your data is overfitting, either your data is memorizing rather than learning. Either the model is memorizing your data rather than learning from the data. So there is no 100%. إذا لقيتي 100% يجب مراجعة حساباتك مع البيانات. Even 95%, there is a risk. 95%, there is always going to be a question. So as data scientist, this is one rule of the thumb. يعني rule قانون ذهبي، قاعدة ذهبية. إلا لقيتي result ديك النتائج ديالك قريبة ل 100%، راك درتي شي حاجة خاطئة. Okay, you have done something wrong. Just go back and check it out. وهاد 100% باش كتقارنيها compared to what? What are we comparing this 100%? This is something we are going to learn in the program. So we need to compare it with something in the historical data. That is what we call base model or the dummy model. And we are going to learn that later in the program. Okay, Satri Jihad, just be careful. If your end result is very high, then you could have done something stupid in the pre-processing phase. Okay, so as a data scientist, كعالم بيانات, you always need to question. خصك دائما تحاول تضع علامة استفهام على البيانات اللي عندك, علامة استفهام على المشكل اللي عندك, علامة استفهام على الناس اللي خدامين معك, علامة استفهام على البروسيسز اللي درتي, processes اللي درتي مع missing values, the process that you took to deal with outliers, whatever process that you use to normalize, factorize, binarize, the process that you took to fix the distribution, to normally distribute your data, whatever process that you use to deal with categorical data, always you need to question them, and finally you need to question the end result. ماشي غير عطاتك 100% wow boom I'm done, you know, I got the best. No, you need to question that 100%. So your job as data scientist is to keep asking questions. من البداية ديال البروجيكت ديالك وانت كتضع احتمالات و assumptions و great questions. So don't believe the processes you are taking as right. Don't believe the question you are working on as the right question. Don't assume and believe the results are great. يعني you always need to ask questions. كاين واحد الكتاب جميل جدا نوري لكم. Yeah, this is the book. Yeah, this is the book. It's called Journey to Data Science. يا كتاب صغير جدا وفيه معلومة مهمة. As data scientist, you always need to ask questions. You need to question the process. You need to question the data. You need to question the results. You need to question the team. You need to question the business problem. So you always need to be skeptical. خصك دائما مشكاك. يعني عالم بيانات خصك دائما تكون مشكاك. دائما وضع الشك في النتيجة في الميثود اللي استعملتي. هذا هو يعني عالم بيانات متميز. ماشي دغيا تصدق عندك 100% وتجري تقول business okay I got 100% I'm done this is great. That is not the case. That is not the case. Okay, folks. So let's fire up. We are going to use now the Jupyter notebook. Okay, and I'm going to dismiss you today or earlier. Tomorrow, inshallah ta'ala, we are going to dive deep into building more graphs. So, as usual, we are going to import the libraries. We are going to import NumPy and Pandas and Matplotlib. So these are the libraries we are going to use. And again, NumPy is used for arrays, array computation or numerical Python. Matplotlib is used for data visualization. Pandas is used for data analysis. And Seaborn, كاين واحد اللايبراري سميتها Seaborn. هاد Seaborn هادي راه مبنية فوق ماتبلوتليب. إلا مشيتو للموقع ديالهم Seaborn Seal Gallery. Yeah, I'm gonna share this with you guys in the chat. You have really some beautiful data graphs that you could use. All what you need مثلا كليك على هذه scatter plot. Copy the codes. وخدم عليهم يعني copy the codes. Copy the codes, and here we go. Just copy the codes and run it, and run it and play around it. Here we go. So play around it. So you got the graph in there, and you need to play to change your data and data variables, and you could have a very piece of art in there that conveys information to the business. So يعني كاين scatter plot, كاين a box plot, كاين a John grid. There are a lot of some beautiful violin plot, which is a combination of density plot and histograms. And كاين بزاف ديال graphs هاد ديال Seaborn. So Seaborn is built on the top of Matplotlib. Matplotlib is the main library اللي غادي نستعملو data visualization. So إلى عندك أكواد. If you have codes that you already used in Matplotlib, if you have the codes. أنا غادي نوريكم واحد العملية زوينة. Okay, so we import NumPy, Matplotlib, and Pandas, and we also import Seaborn. Okay, I'm gonna go very quick وغادي نرجع باش نوريكم الفرق ما بين Matplotlib أو Seaborn. غادي نقراو البيانات ديالنا. I'm gonna go all the way to the graphs باش تعرفوا الفرق ما بين Seaborn أو Matplotlib. Okay. هذه Seaborn. This is a Seaborn. I'm sorry, this is Matplotlib. This is Matplotlib. Okay, أنا غادي نرجع لفوق. غادي نقوم بواحد يعني small change. Okay, small change. I import NumPy, import Matplotlib, import Pandas, import Seaborn. وغادي نقول للسيستم يعني استعمل لي Matplotlib، ولكن حاول تجبد لي حاول تستفد من functionalities ديال Seaborn. How do we do that? By simply setting in this line okay, trying to block مع الأسف. Here we go. Yeah, in line number 8 SNS هي الالياس ولا الشورت كات اللي عطينا Seaborn، ودرت ليها دوت set. هاد اللاين هذا كيقول السيستم yes إلا كنت مستعمل Matplotlib codes, please go ahead and borrow the functionalities from the Seaborn. And I'm going to run this. Okay, and وغادي ننزل لتحت. Then I'm going to run the same graph for the target variable. وغادي تقارنوا الكواليتي ديالهم بجوج. شوفوا هذه كي دايره وشوفوا هذه كي دايره يعني of course you are gonna use the Seaborn. It's the same, you are gonna get the same, ولكن Seaborn is more beautiful in terms of presenting your values into graphs. وكيفاش غادي نستافدوا من capacity or the capabilities ديال Seaborn? Simply use the line dot set. Okay, folks, so let's stop here. And see if you have any question. Any concern, please? Any question or concerns, please? Questions, concerns? Okay, so let's continue working through the file. So last week we talked about the describe function, which helps us to understand the 5-number summary of John Tukey. So John Tukey talked about 5-number summary. What are they? John Tukey talked about the 5-number summary. Okay, the 5-number summary is nothing but the minimum 1 2 25%, 3 50%, 4 75%, 5. This all called the 5-number statistical summary of John Tukey. هذا العالم الرياضيات هو اللي اخترع هذه المصطلحات هذه. So this 5-number summary, they are going to help us understand the statistical significance of the data. أعطيتكم مثال ديال age إلى لقيتي شي حاجة أقل من 19. There is nothing wrong with having a number less than 19 or a number greater than 65. There is nothing wrong with that. But when we are connecting these values with the domain of our insurance, then we get some serious problem. Okay, that is why we need to filter, investigate, and go through every element, the 5-number summary of every element of your data, to just make sure that these values do make sense statistically. Yeah, the 25% is the first quantile, the 50% is the mean, 70% is the third quantile. Then we talked about the objectives. And the objects. This describe only works for numerical data, but if you were to include categorical data, you got to add include object, you got to enforce it. And for the categorical data, we are going to have we are not going to have the 5-number summary. 5-number summaries only apply to the numerical data or the quantitative data. For the qualitative data or categorical data, we have different measurement: unique, the top, and the frequency. And of course, you need to investigate your target variable. So we have some values in there, and this is very important. Understanding what you have in the historical data will determine what you are going to have, is going to determine how to measure the accuracy of the data. So we got 75% of your data is 0 and 25% of your data is 1. So if you build a model that is 80%, do you think it's good or bad? If you are comparing 80% to 100%, is bad. But if you are comparing 80% to what you already have in the data, this is what we call the dummy model or the base model. I think 80% is good. 85 is good, 90 is good. Anything that is above 75, is going to be good. And we are going to learn this later in the once we get into machine learning. Okay, so now we are going to do looking into measurement. Data visualization. Okay, we are going to visualize, and the first thing we got to do, we are going to build some histograms on few variables, and we are going to stop here. We are going to continue tomorrow, inshallah, learning about different, and we are going to learn about the categorical data. The bar plot, histograms, scar plot, heat map, correlation analysis tomorrow, inshallah. But let's run this, and we will stop here. So I created a subset of the data, and in that subset I simply passed into it some numerical data, and I built a historical histogram on this subset. So we got an age, we got month as a customer, we got capital gain and capital loss. As you see, capital gain and capital loss, we have some serious problem. We have one outlier in capital gain, and that is we have many zeros, and we got an outlier in the left tail of capital gains, and we got an outlier in the right tail of capital loss. For the age, it's almost normally distributed, but we got some problems in there. For month as customer is totally not in a good shape. So we are going to stop here, unfortunately, but tomorrow we are going to continue from we got left. We are going to build some different graphs, and not only building graphs, we need to look for insight from we need to have graphs that tell a story. So any question, concerns, please? Any question, concern, please? Okay, folks, that's it for today. I'll see you guys tomorrow, inshallah. Until then, you guys have a great rest of the day. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh.